Alright, last bit of these notes, I promise. We're going on to composition functions, which are those weird things that look like it says fog or goth, or f of g of x is more of how it's read than anything else, or g of f of x, or f composed of g. There's a lot of different ways to read this. It's just funnier to say fog half the time. So if I refer to it, I'm referring to composition functions, but technically it should be said f of g of x. Alright, why is that? Because we are going to go ahead and we're going to plug in x into g first, and then we're going to plug in whatever answer we get for that g of x into that f function where x was. Alright, so example 6, the first thing that we're going to look at is we see, hey, if I've got f of x is equal to 1 minus x squared, and g of x is equal to the square root of x, we need to find g of f of x. So what this means is we need to plug in that. We start with the inner, and then we work our way out. So we need to go ahead, plug in x into f. Well, guess what? We already have f of x. That makes our lives a lot easier. So now, anywhere that I see an x in the g function, I need to plug in that f of x function. So what that means is I've got that g of x is equal to that square root of x, but g of f of x, well, we're going to have that equal the square root of f of x, and f of x is represented by that square root of 1 now minus x squared. Alright, so that's it. That's all. That is g of f of x. The only thing that we've got to do is try to find the domain of this g of f of x, which isn't nearly as fun. So remembering way back when, to at least last section of notes, if not last year, stuff underneath the square root cannot be negative. So we've got to make sure the stuff underneath the square root is going to be positive. So we set 1 minus x squared is greater than or equal to 0. We solve for x. So I get negative x squared is greater than or equal to negative 1. I divide by 1. I get x squared is now less than or equal to 1. Because if I divide by a negative, that sign changes. If you guys need me to go back through that algebra 1 tomorrow, I can. And then in order to get rid of that square root, what actually ends up happening is instead of putting a square root there and acquiring that plus or minus, what we're going to do, since it involves an inequality, is we're going to counter that plus or minus by just saying the absolute value of x, that way it stays positive, is less than or equal to 1. So therefore, my x should be between negative 1 and positive 1. Cool. And they can both be included because, well, it started off as included. So we're good. Alright, so my next one isn't nearly as bad. I'm just going to switch colors for the fun of it, maybe. I like blue better anyway. So it says if f of x is equal to that 2x minus 1 over x plus 3, and g of x is equal to that 3x plus 1 over 2 minus x, find f of g of x. Based on our answer, how might g and f be related, or f and g be related? Alright, so I'm going to probably need some more room, I'm not going to lie. So I'm going to zoom in a little bit. Alright, so the first thing we got to do is make sure I've got x plugged into g. I do, because that's what g of x stands for. So we can go ahead and plug in g of x anywhere that we see an x in our f of x equation. So I've got f of g of x. So what's going to end up happening is I'm going to have 2 times g of x minus 1 all over g of x plus 3. Alright, and then I just plug in what the heck g of x was. So it's going to be fun times. I've got f of g of x is equal to 2 times the quantity of g of x, which is represented by that 3x plus 1 over 2 minus x. And then minus 1 all over, again, that 3x plus 1 over 2 minus x plus 3. Alright, so now we can simplify this out. What I'm going to do first, there's a couple different ways to deal with fractions. I'm honestly just going to try to make one really big fraction up top, one really big fraction down below. So I am going to multiply this 1 by that 2 minus x, and I'm going to multiply the 3 down below by 2 minus x. Technically, this 3 is over 1, so I also need to multiply that denominator by that 2 minus x. Just like up here, this 1 is also 1, so I need to multiply that by 2 minus x as well. Alright, seems nice enough because they're both being multiplied by the same thing, but we'll see. It's a trip. Alright, so up top, I end up with 2 times the quantity of 3x plus 1 minus 1 times the quantity of 2 minus x, all over 2 minus x. This is all over 3x plus 1 plus 3 times the quantity of 2 minus x, all over 2 minus x. Alright, so now we just get to distribute this out. And so we should end up with 6x plus 2 minus 2 plus x all over 2 minus x all over. That should still be 3x plus 1 plus now 6 minus 3x, still over that 2 minus x. Alright, combine your like terms just to kind of clean it up a little bit. Cancel if you can, which in this case we can because these 2's cancel out, leaving me with just a 7x up top over that 2 minus x. All over my 3x's cancel out, leaving me with just a 7 there over that 2 minus x. Alright. So now keep copy dot flip, keep change flip, whichever one you want to call it. From middle school, that was kind of highly effective. So then I've got copy, which is that 7x over 2 minus x, dot 2 minus x all over 7. So these are the same up top and on bottom. And then I just get 7x over 7. Reduce the 7's down, which is leaving me with x over 1 or just x. So what this means is that f and g are probably inverses, because remember it said, hey, based on our answer, how might f and g be related? So they can possibly be inverses, because if f of g minus g of f is equal to x, then they are going to be inverses, but that I'm going to leave you guys. If you want to try to see if they are inverses or not, that's up to you guys. But because we got the answer of x, they could possibly be inverses. Other than that, I was joking about having a unit circle quiz tomorrow. There will be one soon after we really in-depth review sine, cosine, and tangent. But do expect that becoming this chapter. It's not too far away, but it's definitely not this section. Other than that, have a really great day. I will see you tomorrow.